Have you ever stopped to think about how the code we write, in actual human-readable words, somehow gets turned into something a computer can actually run? It feels a bit like magic, right? Well, today, we're going to pull back the curtain and look at one of the most fundamental ideas in programming, how that translation actually happens.
I mean, this is the core of it all, isn't it? We're over here typing things like print this or add that, but deep down, the computer's processor only gets one thing: a massive stream of on and off signals, just ones and zeros. So, how in the world do we bridge that absolutely gigantic gap?
And this right here, this shows you the problem perfectly. On the left, you've got a command that makes total sense to us. On the right, that's what the computer needs to see. It's a completely different language. To bridge this gap, we need special translator programs, and they really come in two main flavors. We call them compilers and interpreters.
Okay, so first up, let's talk about the compiler. I always like to think of the compiler as this super meticulous planner. It's incredibly thorough, and its whole philosophy is to get all the work done up front before anything else is allowed to happen.
The key word here is entire. A compiler doesn't just peek at your code, it reads the whole thing, from the first line to the very last. And after it's analyzed everything, it spits out a brand new, totally separate file, an executable. And that file is pure machine code, ready for the computer's processor to understand and run directly.
So the process is super methodical. Step 1, it reads your entire program. Then, step 2, it goes through this really intense analysis phase, checking for any syntax errors, optimizing the logic, basically making sure everything is perfect. If it finds even one tiny mistake, it just stops and tells you right there. Only when everything checks out does it finally move to step 3 and create that final runnable file.
So, what's the reward for all that upfront work? Well, it's all about speed. Because all the translation work is already done, that final program runs incredibly fast. The compiler took its time to optimize the code for that specific computer. And maybe the biggest win for developers is that it catches typos and silly mistakes before you even try to run the program, which, trust me, saves you a ton of headaches.
But, of course, there are trade-offs. That initial compilation step, yeah, that can take a while, especially if you have a huge project. And if you want to make just one tiny change to your code, you have to recompile the entire thing all over again. This can make the whole development process feel a little slow and rigid sometimes. So where do you see compilers out in the real world? Well, they power languages where performance is absolutely non-negotiably critical. We're talking about things like operating systems, big-time video game engines, or high-frequency trading systems. This is where languages like C++, Rust, and Go really shine, all because of that raw speed you get from compilation.
All right, now let's meet our second translator, the interpreter. If the compiler is that meticulous planner, then the interpreter is the complete opposite. It's a spontaneous, on-the-fly translator that does all its work in real time.
So, this is a totally different approach. An interpreter doesn't create some new, separate file. Instead, it runs right alongside your code. It reads one single line, translates that line into machine code, tells the computer to run it, and only then does it even look at the next line. It's this continuous loop: read, execute, repeat. Read, execute, repeat. And this whole process happens every single time you run the script. There's no prep work, no pre-compilation step. The translation and the execution are happening at the same time, live, while the program is running. Now, this way of doing things has some huge advantages, especially for the person writing the code. It's just so flexible. You can make a change to your code and immediately see the result, with no waiting around for a long recompile. This makes it amazing for things like scripting, web development, and honestly for anyone who's just starting to learn how to code, because that feedback loop is so quick. Okay, so what's the catch? Well, it's performance. Because all that translation work is happening while the program is running, it's just naturally going to be slower than running a pre-compiled program. It's also using up more of your system's memory and CPU. And here's the tricky part. An error on line 50 of your code won't be discovered until the program actually gets to line 50 and tries to run it.
We've met our two contenders. We know their styles. Now it's time to put them side by side for the final showdown.
Look, if you only remember one thing from all this, let it be this right here. The compiler does all the work up front. The interpreter does the work as it goes. That single difference is the root cause of all their strengths and all their weaknesses.
This table really breaks down the trade-offs. For translation, you've got a big batch job versus a real-time line-by-line job. When it comes to pure execution speed, the compiler wins. It's not even a contest. But for error checking, it's more of a philosophical difference, right? The compiler is proactive. It finds problems before you can even start. The interpreter is reactive. It finds problems as they happen. So to make all this really stick, let's use one last really simple analogy that I think perfectly captures the difference in their styles. Don't think of them as computer programs. Instead, think of them as two different chefs.
I mean, that really says it all, doesn't it? The compiler chef has your entire perfect 3-course meal ready and on the table the second you sit down. It's incredibly efficient to eat. The interpreter chef, on the other hand, is standing right at your table cooking each bite to order right in front of you. It's a much slower meal, but it's incredibly flexible and responsive to exactly what you want in that moment.
And that, of course, brings us to the final question. So, which one is actually better? And the truth is, that's the wrong question. Neither is better. They are different tools for different jobs. Are you building a high-performance game that needs every last drop of speed? You want the compiler chef. Are you building a website or analyzing data where you need to experiment and change things quickly? Well, the interpreter chef is going to be your best friend. The choice always depends on what you're trying to build.